will do the same thing which we do right now?
Well, at the heart of it, yes. I mean, programming is programming. So, like when we are doing something like read something in from the user to go north or south or east or west or something like that in the cave, when we read something in from the user like that, the only difference in modern day stuff would be somebody presses a button for the exit or something like that that translates into that number. But the problem is the amount of work that goes into building even a simple graphic user interface to do that is pretty steep. Once you learn it, it's not that bad, but it would take us probably half of this course to get you far enough into graphic user interface programming to be able to write that.
Okay.
Um,
Why I'm asking this question?
mhm.
If you remember the tower thing,
Yep.
Tower of Hanoi.
Yep.
It was created one list, Tower of Hanoi.
Yep.
With build up library, everything there. So for buttons, they just write down button this one, and you just need to click the button.
Mhm. Sure.
And whenever you start to play, I mean the play means like run the driver, it will be like pop up another window. It's like it's not too much line as we do here, like because we are creating ourselves and like. But the thing is, if we learn how to use existing
Yep.
codes, wouldn't this would be easier for us to learn?
It would be easier to write Towers of Hanoi, yes, but you wouldn't have gotten to experience some of the algorithms that we went through to solve problems because we would have used graphical things like you would have had this disk collide with this disk, which makes it stop falling. That type of thing, where the disks were physically stacked on top of each other, rather than us doing the calculations to determine where in this stack should this disk go and that kind of stuff. So you lose out on some problem-solving aspects of it.
Okay.
Because you let graphics take over. Graphics and physics take over. So, it's kind of a trade-off. Ultimately, what you want to do is you want to produce graphical stuff like that. But right now, we need to really drill in the problem-solving aspect. I mean, the same thing's true with this cave crawler thing. To write this graphically would make more sense. But right now, we want to try to visualize this data structure, this kind of tree, this n-ary tree data structure with all the, you have a cave, and then you have a bunch of rooms coming off of that, then a bunch of rooms coming off of that, a bunch of rooms coming that, and now you want to kind of capture that inside your head and try to visualize where I am in the world. Whereas if you saw it graphically, it would help you do some of that. It would help you visualize it, where we don't really... We don't want the crutch right now.
Yeah.
Well, we might want the crutch, but the crutch doesn't help us yet. We want to appreciate the complexity of it, then we can visualize it secondarily.
Yeah. No. Yeah, I got it.
Does it kind of make sense?
Yeah.
Okay. So let's start off talking about the...
It's not how it goes.
Talk about the paper first, which was on MUDs, correct? Okay. So, was write a 2 to 3 page paper discussing the concept of a MUD as it relates to multi-user dungeons. These were text-based Dungeons and Dragons games similar to what you are writing in your homework assignment this week. What was the first MUD? What were the different types of MUDs? Do people still play MUDs today? What modern game genre has largely replaced MUDs? Okay, so let's go in order here. So what was the first MUD?
The first MUD-related game was the dungeon featured game would be Colossal Cave Adventure.
Cave Adventure?
Yep.
Okay.
1975.
Okay. All right. Let's see.
And MUD name game created.
What were the different types of MUDs? So as you looked at MUDs, you probably saw things like moos and so these guys came in a couple different flavors. What did you find out about that?
Oh, moose. I mostly look like Ebermud, Tiny Mud.
Okay.
Like types of mud.
Okay.
So different types, and by the time being they are updated, like upgraded, most likely for the for some group of people, like socializing or playing adventures or playing versus to each other. I mean, most likely not versus because the mod's not.
Okay. So some of them were more geared towards social interaction.
Yeah.
Some of them were more geared towards kind of fighting monsters and things like that. Okay. And they, some of them had different names and stuff like that. But
role-playing games.
Okay, some were role-playing specific. Other ones were just hack and slash, just go and kill stuff. So they really started off as this concept of let's bring people who are not sitting locally in the same room together online. This was the first kind of experience. I mean, we take it for granted today. If you play Xbox or something like that, you have Xbox Live and you launch Madden football, and next thing you know, you're picking an opponent who, for all you know, is halfway across the world. Well, this wasn't always so easy. Back in the early days of the internet, just getting a bunch of people online in the same room together was a major feat. We had all sorts of problems that don't even exist today. You think about
memory efficiency.
Well, not even that. Connecting to the internet.
Oh, yeah.
Now we just imagine that we're just on. We're on the internet. Where back in the mid and late 90s, you dialed into the internet. With a dial-up modem. And when you dialed into the internet, you were dialing into one of several phone lines that your internet service provider supported. So you'd hear all the beeping and crap like that. You connect. Well, how many people can be in a MUD at a time? Well, in the early days, the number of modems that they have. The MUD actually lived on the server, on the central server. One of the popular MUDs was on a service called Prodigy. And so Prodigy was kind of a predecessor to AOL, America Online.
Okay.
So you would dial into your local Prodigy server, and they would have the dungeon running on there. And how many people were playing in the game at any point in time? Well, the number of modems that the local Prodigy provider had. That might mean you had 16 people maximum in the game at a time. Now, interesting thing is, let's say, so Prodigy was a service, so you could go on there, you can play games like that, you can check your email, you can do, primitive web browsing. This is really before graphical browsers existed, so this is all text-based at this point in time. So imagine the situation where you want to get on and check your email, but you can't because all the modems are being taken up by a bunch of people playing these stupid games. Those were real situations. Right? So the world's a lot different today from an internet perspective than it was back then. Those were the very early days of the internet. And really, even today, the internet's not that old. I mean, the internet's 20 years old. Right?
The first internet probably less than that.
1996 or so is really when internet became pretty mainstream, where you had a growing number of people who had dial-up access at home, and they had graphical web browsers. Netscape existed. That's the predecessor to Mosaic, which is the predecessor to Firefox. So 96, 06. So really 20 years, is probably about when the internet existed. About 20 years ago. And that's not that long, right? Can you imagine? I mean, think about how you use computers today. Can you imagine life before the internet? Today. Now that we've gotten so adapted to it, right? Like when I said, today's quiz is going to be who won the Masters, you immediately say, oh, I have Google.
Yeah.
1996, what would you have done? Gone and find a newspaper or something, right? So, very, very different world, and our philosophies change. Somewhere in the middle there was times where, people have always been addicted to different things, addicted to games, things like that. Well, as video games became mainstream, you had this whole idea of video game addiction. Well, or even internet addiction. People just get addicted to being on the internet because they had at their fingertips information that was never there before. Just information overload, right? So you'd have situations where families would have to get a second phone line because nobody could call them because somebody was taking up the phone with the dial-up.
Oh, yeah.
Okay? So these were all kind of interesting things that existed with this, in this time frame that where MUDs existed. Okay. Do people still play MUDs today?
I believe so, because when I check out internet websites, there's some MUD, online MUD games. One of them, mudconnect.com, which has like more than thousands MUD connection. Like it has like from 1992 or 3 till nowadays MUDs, which is most likely graphical virtual machine works in there. Like, it has graphics. I don't know.
Okay, it's still text-based, but
text-based, but yeah.
A lot of them use what are called ANSI graphics.
And yeah, and there's another MUD online game, airwolf.com.
Okay.
Which at the same time they informing that there is like 400, 500 people playing at the same time, which is pretty much still.
So the short answer is people do still play MUDs.
Yep.
But far less than maybe historically played. Correct? Why is that? Because of our modern video games, right?
Yeah,
Okay, so what genre of video game did MUDs evolve into?
They most likely changed the types of the games, like GTA, World of Warcraft, which is virtual avatar players, video players.
Yep.
And
so games like World of Warcraft are probably the best examples. So these are massively multiplayer online role-playing games, MMORPGs. And this is a single world with a lot of people in it. And these people have the ability to socialize with each other. They have the ability to fight monsters and stuff like that with each other. There's things that happen within this virtual world, right?
Mm-hmm.
So a game like that, World of Warcraft, Guild Wars 2, those types of games, they would be very much like your traditional multi-user dungeon, the Dungeons and Dragons hack and slash type thing. Now you get to some of these social type ones like the MOOs, the historical MOOs, MOOs. You might go to things like Second Life. So Second Life is, how many of you have heard of Second Life before? Any of you read anything about that in your paper? Second Life is a virtual world where you get an avatar and you can build stuff in the virtual world, and some people do virtual conferences and stuff like that within Second Life. So Second Life is very much social in nature. There isn't a point to it. It's not a game where you go in and you play a game and there's a goal. Instead, it's a world that you live in virtually, and you can do things within that world using the tools that you have available to you. So some people have created kind of games within Second Life using the tools that Second Life provides you. But Second Life in and of itself isn't a game. It's a infrastructure for a online social community. Kind of our modern day chat room. Mm-hmm. Chat room with dimensions. Okay? Similarly, another thing you maybe discussed was something like Minecraft. Any of you play Minecraft? Or know of Minecraft? Okay, so Minecraft is somewhere in the middle. So Second Life is all about social and you can build crap or whatever, but there's like no reason why. World of Warcraft has a very specific gameplay style. You can go on there and you can fight big dragons with other people, and you kill the dragon, it drops good loot, you put the loot on, and people think you're better than them. It's a game. Okay, people understand that there's a game aspect to it. You take something like Minecraft. Minecraft has a social aspect to it where you build things and stuff like that. It's also created kind of a giant social buzz on the internet where you have people who create kind of videos based on Minecraft, right? You've seen all sorts of spoofs and stuff like that. People making the Minecraft version of different music videos, doing it in Minecraft graphics, because Minecraft isn't a good graphics type thing, right?
Yeah.
But it's a specific type of graphics, very blocky type graphics,
Yeah.
correct? So if somebody does something in the Minecraft style, you recognize it immediately. Just like the Lego games. The Lego games, they're not graphically intensive, but people like them because they're very good graphics when you consider that everything's made out of Legos. Make sense? Well, Minecraft is kind of a halvesy type thing where a lot of it's social and you can just kind of do whatever you want and build things, but then there's a game aspect to it that allows there to be some level of competition or something like that. So those types of things are really kind of our modern equivalent to MUDs. Let's see, what else do I... Okay, that was that part. So, having said that, are MUDs dead?
More likely they are upgraded.
Okay, well, so definitely something like World of Warcraft is a modern day MUD. But in context, multi-user dungeons being these text-based things, are they dead? Maybe no more dead than the predecessor to MUDs. What came before MUDs? Before we had any sort of internet connectivity, what did they do when they wanted to play these games? They still do it today. People make fun of them.
Connecting with each other, just speaking?
Well, sure. Dungeons and Dragons. The original tabletop role-playing games.
Oh, yeah.
Where you're sitting there with your dice and you're rolling the dice and you're going to say, okay, I attack the ogre, blah, blah, blah. You know, that used to be what people did for fun. The geeks, the nerds, whatever, okay? Then what happened? Well, then technology came in. So some of the older folks made the transition to MUDs. But the younger folks who would have probably gone in to become the nerdy tabletop gamers, they became MUD players. Because that was what was available to them, right? You know, so then those people got old. So now today, somebody's into this kind of thing. The people who play these games like World of Warcraft and stuff like that today, these very well might be the same people who would have played MUDs 15 years ago. Or tabletop Dungeons and Dragons 25 years ago. Does that make sense? So if tabletop Dungeons and Dragons exists still, which it does, a lot of people still play those games, interestingly enough. There's groups here on campus of people that get together and they
play Dungeons and Dragons on the table?
That's where it started. That's where Dungeons and Dragons started.
I know, but
they still do it. Yeah, there's groups around campus here that do that.
It's pretty crazy.
But now it's more of a people play it that way because it requires a lot of imagination. So you think about your modern day games, how much less imagination they require than some of these older things. You know, a MUD, you just have screens and screens of text scrolling by. And at first you're like, how can anybody read this? But when you start playing a MUD, you learn exactly where to look on the screen. So you can actually go from place to place to place, and it feels like a video game to you. And even before that, when you had tabletop Dungeons and Dragons, okay, well, you know, now that takes complete imagination, right? One of the guys in tabletop Dungeons and Dragons, his job is to be the dungeon master. He plays as all the bad guys, and he sets up the map, and you've entered a dark and scary cave, and there are ogres here, blah, blah, blah. So very, very interesting, the evolution of these things. But I'm not sure we could ever say that something is dead, right? You know, there's always going to be people that still play these things. And then you also have resurgences where, you know, people go back to things the way they used to be because things have gotten so over the top today that there is no real room for imagination. You know, video games today are so graphically intense that it requires no imagination, right?
Already it's imagined.
Yeah, it's already imagined, exactly. Okay, so that kind of makes sense. Any questions about the paper, the MUD thing?
I could not totally understand why they in the beginning they do not allow to having like a player to player MUD, like player versus player.
Mm-hmm.
They do not like most likely like player killing, PK.
Mm-hmm. But they do exist.
I know they do.
There's
exist,
plenty of
but
mods that have PKs.
Why they don't like it, or they restrict it most likely.
Well, my guess would be this. Okay, so your question is, why did many of the early mods not support PvP, player versus player fighting?
Which is today, like, pretty much.
Well, it's at least a major part of a lot of games today.
Yeah.
Part of the reason is I think that that PvP, player versus player type stuff, is very much skill based. So people who play these first person shooters today. Let's talk about in terms of modern day games, Battlefield or Halo, those types of things. These first person shooters, there's a lot of skill involved in that, and you need to have a human being playing that game needs to have a lot of input coming into them so that they know how to react to different situations. I think that type of experience would be very difficult to translate text-based. There are PvP-based MUDs, however. But, so an example, I played one for years where you could be dragons and stuff. And every 2 hours, the whole game would reboot and go into a game mode where it was a player killer mode. So for the next 20 minutes, everything was a free-for-all, kill whoever you can kill and get points, blah, blah, blah. And what would happen is you would be on this map and you'd be going from room to room to room. But imagine when you come into a room, there's going to be 5 enemies in the room, let's say. Well, they're attacking you at the same time as you're attacking them, and there's so much stuff going on the screen that it becomes information overload. So I think that a lot of times the skill aspect of it goes away because there's so much stuff going on that it becomes kind of luck and just overwhelming and maybe even frustrating. Whereas if you look at it from, I'm going around this world and I'm going to fight against non-player character monsters, NPCs. If you come into a room and there's a rat sitting there, maybe not the end of the world. If it takes you 2 seconds to kind of get your bearings on things, no big deal, right? So I think it translates better to lower stress situations like that when you have text-based. Even when you get to our modern day online games, the player versus player stuff like first-person shooters didn't really become popular until our internet connections were fast enough and we had enough technology there so that we could create a situation where everybody was on an equal playing field. There was a game in one of the early first-person shooter games was a game called Counter-Strike. And Counter-Strike, when you would set up a game, and some of the higher level games actually had a kind of an internet connectivity minimum. So depending on what your ping rate was, they might kick you out of the game. If your internet connection wasn't good enough, they would just kick you out of the game.
Okay.
That doesn't really exist anymore. Now it's like everybody's internet connection is pretty much good enough. You know what I'm saying?
Yeah.
Where that didn't always exist. So that's part of the evolution of the technology, I guess. All right, what else? Okay. So, hello. Let's go and let's look at our first part of our dungeon crawler. So we had a starting point. I give you the starting point for code. So we are to update the crawler game to allow a user to traverse the cave. They should be prompted in each room to pick an exit or quit. Every room they enter that has a treasure, they should earn 1 point. Once they quit, the total number of treasures collected should be displayed to the screen. You should also display the total number of rooms visited. You do not need to let them start over, and you cannot move backwards in the cave. Okay, so this is kind of part 1 of our little cave game. So let's go back into Eclipse here, and let's see where we left off. So right here, here's our driver, and what we're doing right now is we created a new cave named C, and if you go into a cave, we see how caves get built. A cave has an entrance. That entrance is a brand new room. So this is where that room is born. So we go into the room constructor. The room constructor uses our random number generator to generate whether or not we have a treasure, whether or not this room has a treasure, and then we're updating our little stats object. That's our stats class object for the total number of treasures that are in there. We were going to come back and work with some of those stats today. Then we create a linked list of rooms that will represent the exits for this guy. And then we randomly generate the number of rooms, either 0, 1, or 2 rooms that will come off of this. For each of those rooms, we'll add it to our list and create a brand new room. Brand new room, we'll call that room's constructor, which will generate whether or not it has a treasure, blah, blah, blah. Okay?
I have a question about
Sure.
the exits. Does it mean like exits means like entrance, another entrance, or it is exit? Like,
Well, another entrance. So like if I'm in this room right now, this room has 2 exits. That door and that door. Those are the places I can go from this room. Does that make sense?
mm-hmm.
So I can walk through this door and I'm in that room. I can walk through this door and I'm in that room.
Getting this thing is really frustrating because exit means like going out.
Well, it
It's
does.
like
We're going to
going
leave this
in.
room through that exit to go into another room.
Yeah, I know, but the meaning of it, like you have to enter to another room by the going exit, right? That makes sense.
Okay, so right now in Driver, we create our cave. So this is going to organically grow that cave, right?
Mm-hmm.
So we're going to get some number of rooms because it's going to sit there, and until our random number generator finally generates a bunch of zeros, so we have cave endings, it's just going to keep going. Then we're going to print out how many rooms this guy created and how many treasures it totally created. Okay? And then we have a play method that just displays the entrance displays a current room. Okay, so a room, its display method shows the word a room, then has the word treasure, and then if it says it has treasure, if this room did have treasure randomly, then it says a pot of gold, otherwise it says none. Then it says obvious exits, and it'll print out 0, 1, 2. So if there's no exits, it'll say none, otherwise it'll print out 0, 1, or 2 for the exits you can go through. And then we're going to prompt, what would you like to do? And then we gave you a little hint here. This might be where you want to add some crap for your homework.
0, 1, 2, 0 means none, right?
No, I mean each room has either 0, 1, or 2 exits.
0 means non-exit.
Well, you can decide how you want to interpret it. I don't have anything that interprets it right now. I'm just spitting it out.
That's why I put my equation there.
So here, if we run this, the first room we're at has no treasure, but it has 1 exit. That exit's 0. So we can have up to 2 rooms, or up to 3 exits rather. We can have 0, 1, 2, or the maximum number of exits. Or we can have 0 and 1, or we can have 0, or we can have none. That make sense? So in our little map here, we got 2 rooms, and there's only 1 treasure. We can run this multiple times, and sometimes we'll get here. We have 154 rooms this time. Notice this first room has 2 exits, an exit in 0 and an exit in 1. Okay? So we need to have the user enter in information as to what room they want to go into. Okay? So to start with that, we're going to prompt the user. So after a room displays itself, it's then going to read some stuff in from the user, asking them what they would like to do. All right? So what I'm going to do is I'm going to write another method here inside of room. We could have put it inside of display, but I'm going to write it inside of room here. I'm going to make this guy private. Let's do int get input. Okay, so get input's going to actually ask the user for some stuff. So we're going to first create our scanner. Scanner input is equal to new scanner system.in. And we're going to have to import java.io.scanner, or java.util.scanner rather. Okay, now we're going to prompt them system.out.print Right now, we're prompting them down here. We're saying, what would you like to do? I'm going to go ahead and move that print statement up here into our get input. And I'm going to say print, not println. That way it gives us our little prompt. So it's going to say, what would you like to do? Then we're going to say string line is equal to input dot is it next line? Yeah, there we go. Input dot next line. That'll read in a string. Now, after we say what would you like to do, I'm going to give a little prompt there. I'm going to say press Q to quit. So what inputs are we expecting from them? We're expecting a 0, a 1, a 2, or a Q. Does that make sense? Okay, those are our possible inputs in our game. 0, 1, 2, or Q if they want the game to be over. Okay, we'll evolve that in today's class where Q actually means maybe they go back to the beginning. But for right now, they can quit the game, and our assignment says when they quit, once they quit, the total number of treasures they collected should be displayed to the screen. You should also display the total number of rooms visited. So we're going to have to keep track of those things as we go through the game. All right?
There's a question about the... You said there is 3 rooms we choose. 0, 1, 2, right?
Well, for rooms that have 3 exits.
3 exits.
If they have 3 exits,
Okay.
there's 3 rooms. Some rooms only have 1 exit. Some rooms have no exits.
Okay. 1 till through 3 exits. So we have to put input number for scanner 0, 1, 2, right?
Or Q.
Or
Q to quit.
There's like 4.
That's what we're going to do. And the thing is, we're making that decision right now. You could have gone a different direction in your assignment.
Mm-hmm.
That's what I'm deciding to do here.
Okay.
Okay? I'm going to say, here's your obvious exits, 0, 1, or 2, or 0 or 1, or just 0. And then I'm going to say, what would you like to do?
Okay.
Okay? So we're going to ask them what they would like to do. We'll read it in if line dot equals Q. So if they entered in a Q, I'm going to return a -1.
Mm-hmm.
Just -1 means they want to quit. Because this method I'm writing here returns an int. So I'm deciding that a -1 means they want to quit. Okay? If they didn't enter in a Q, they must have entered in a number. Else, just for some error checking, I'm going to go ahead and I'm going to make sure they entered something in that is a number. If line dot, let's see, what do I want to do here? Actually, we'll do this. We're going to do a try catch. So I'm going to try to return, actually I'm going to do it this way. Int num is equal to integer.parseInt line. So this is how we convert a string into an integer, using integer.parseInt. Okay? Now, there is no guarantee here that line holds a number. They might have put in the word dog. If I try to get an integer out of dog, I'm going to get a number format exception. Dog is not a number. Okay? That's why I'm going to try to do this. And if something bad happens, I will catch the exception. And if they entered something that was not a number, and they entered something that was not a Q, what am I going to do? I'm going to return this dot get input. I'll call this method again, because we need to prompt them again. Okay? Maybe I even give them a little notation that says bad input. So system.out.println bad input. So we prompt them, we read in the response as a string. If they happen to enter in a queue, we'll return -1. That means they quit. Otherwise, we'll try to turn whatever they entered in into a number. If it fails for whatever reason, we'll catch the exception so our program doesn't crash. We'll tell them you had some bad input there. Here, we'll even tell them what the input was. Bad input. We'll show them what they entered. Then we'll call this .getInput again. We'll call this method itself from within itself. That's a recursive call. Why? Because getInput knows how to prompt the user for input. Does that make sense? And we'll return that whenever he finally comes out with a number.
Why my exception shows like underline something great?
Because you misspelled it.
Okay.
Right?
Yeah.
All right. Now, assuming we don't get inside this catch, that meant that whatever we did right here is a number. Okay? But we only allow legal numbers. Does that make sense? Well, what's a legal number? A legal number is 0, 1, or 2. Assuming this place has enough exits. So inside of getInput, I'm going to have this guy take in a number. Int num exits. This will tell me the number of exits that this guy has. Okay? If num exits is 0, it does not matter what num is. They have to try again, right? Okay? If num exits is 1, we'll only accept a 0. If num exits is 2, we'll only accept a 0 or a 1. If num exits is 3, we'll accept a 0, a 1, or a 2. That make sense? Otherwise, we need to ask them again. Okay? So this guy is going to ask the question. It's going to say, if num exits is equal to 1, and num is not equal to 0. That means they gave us bad input. Correct? And we'll do this little guy. We'll say bad input, show them what they typed in, and return this .getInput. Now, notice that every single time we call getInput, we're going to have to pass it the number of exits. So if I'm calling this guy again, I'm just going to pass it the number of exits that were passed to me originally. That make sense? So if the number of exits is 1, the only legal input besides Q is 0. Else if num exits is 2 and num is not equal to 0 and num is not equal to 1. If num exits is 2 and the number that you put in is not a 0 or not a 1, then what are we going to do? Tell them they had bad input, ask them again. Else if num exits is 3 and num is not 0 and num is not 1 and num is not 2, tell them bad input, call it again. Else bad input, call it again. Make sense? Now, we can even give them a nice little prompt for what the legal inputs are. So up here where we're printing out, what would you like to do? Why don't we say this? What would you like to do with a question mark? Then let's go through the number of exits. So we'll say system.out.print options Q, then I'm going to say comma, num exits is either going to be 0, 1, 2, or 3. Correct?
Wow, okay.
All right. So we're going to tell them what their possible, what the possible things they can type in here are. So we're going to say options are Q. Q is always an option. It's always an option to quit. Then we're going to say for int I is equal to 1, I is less than num exits I plus plus. We started off at 1 because if num exits is 1, that's the only time we're going to give them some additional exits. I'm going to take the comma off of here. We'll add the comma in over here. So options are Q. Every single time through this loop, I'm going to say system.out.print, comma, space, concatenated with I minus 1. Okay, so let's just say that the number of exits was 2. That means our legal exits are 0 and 1. So I starts off as 1. Is 1 less than 2? It is. So what are we going to do? We're going to print out, actually we need to say less than or equal to num exits. You'll see why in here in a second. So as I starts off as 1, is 1 less than or equal to 2? Yes, it is. So we're going to print out a comma concatenated with a 0. One of our legal exits is exit 0. Spin back up. Then we're going to say num exits. Well, I becomes 2 now. Is 2 less than or equal to 2? Yes, it is. So we'll print out a comma, comma, 1. Finally, we'll close that parenthesis. So this will build an output that looks like, what would you like to do? Open parenthesis, options, Q, comma, 0, comma, 1. Or Q, comma, 0. Or Q. Or Q, comma, 0, comma, 1, comma, 2. With a close parenthesis. So depending on the number of exits, this will give you the appropriate prompt. This is all just wordplay. Make sense? Okay. So that's going to give them the appropriate prompt. Then read something in. If they entered in a Q, return -1. That means they want to quit. We'll interpret that someplace else. Otherwise, we'll try to turn whatever they entered in into a number. If something bad happens in turning it into a number, we'll catch that exception, tell them they had that input, and ask them to do it again. Otherwise, if the number of exits is equal to 1 and the number they entered was not a 0, tell them it was a bad input. Else, if the number of exits is equal to 2 and the number they entered is not a 0 or a 1, bad input. If the number of exits they entered is a 3 and the number they entered is not a 0, a 1, or a 2, bad input. Otherwise, they must have added bad input. Is that true? When do I get good input? If I'm in this else, that means what? That means that this guy is a number. Correct? It also means that all of these guys have failed.
Mm-hmm.
What are my other bad numbers they can enter? They can enter in a number. Well, I know it's a number if I'm in here. I know it's a number. What if they entered num less than 0?
Minus. They'll be bad, yeah.
Or num greater than 2? That's also bad input, correct? If they enter something too small or too big. Up here it says if they didn't enter in the perfect number, bad input. If they didn't enter in the perfect number, bad input. If they didn't enter in the perfect number, bad input. If they didn't enter in a legal number, bad input. Else, return num. Otherwise, they entered in a number in the right range and it didn't fail any of these things up here. So it must have been a number within the realm of 0 to 2 if the number of exits was 2, that kind of thing. Or 0 to 2 if the number of exits was 3. That makes sense? If we survived all these landmines here, for all the things they can't enter, then we'll finally come down to the bottom. Now, how could we have written this more easily? Could have made this significantly shorter. Couldn't we have said, let's just start off with this. If num is less than 0 or num is greater than 2, those are both illegal, right? Or the number they entered is greater than what? Well,
No, greater than.
this guy that we read in is num exits. If num exits was 3, if it's greater than 2, it's illegal. So if num is greater than num exits minus 1. If it's less than 0 or it's greater than 2, even this is redundant. Can't we just say if it's less than 0, it's illegal, or if the number they entered is bigger than the number of exits we have? So if num exits was 3, if the number they entered is bigger than 2, then it's not good, bad input. Otherwise, we have a legal number. It's not too small and it's not too big, so we'll return it. That make sense? Okay. Now, the whole point of this method to get input is to ask the user for some input, read it in, and ultimately return an int. That make sense? That's the whole point of that method. So what I'll do down here in display is after I show them what this room looks like, I'll then say this dot get input, and the number of exits is equal to what? The exits dot size. This dot the exits dot size. Okay? And here I'll store it in a variable for right now. We're not going to do anything with it yet. In fact, actually I will. I'll just spit it back out. So right now I'll call get input, passing it the number of exits for this room. And get input's going to do whatever it can to actually get some legal input from the user. That make sense? And answer should be either -1, 0, 1, or 2. Otherwise, it doesn't let them out of this method. It keeps calling the method recursively within itself until we finally get good input. Okay?
And then you print out it?
Yeah, then I just printed out answer.
Mm-hmm.
So we should be able to run this, and we should be able to give it input that's good, give it input that's bad, and have it keep prompting us. Okay? So I'm going to go ahead and run this. So here, we have number of rooms is 3, very small cave. Number of treasure, 1. Here's our room. No treasure in this room. Obvious exits, we have 1 exit. What would you like to do? Options are Q or 0. Make sense? So it's told me what my legal options are here. I'm going to go ahead and I'm going to put in a 5. It's going to tell me, bad input. 5 won't work. What would you like to do? Why don't you give me a Q or a 0? Okay, I'm going to give it a 1. Bad input. That won't work. Got to give me a Q or a 0. Let's do a -2. Bad input. That won't work. Got to give me a Q or a 0. I'm going to give it a Q. If I give it a Q, it should return a -1. So it should spit out a -1 to the screen. Okay? -1 is what get input returns when we want to exit. We'll have to respond to that, but it gave us the right value, correct? Let's go ahead and run this again. Oh, just so happened, it was just bad luck. Just stuck in a room, no exits. Good luck. All right, let's run it again. So we get here. Ah, nice big cave, 364 rooms. Okay, obvious exit, 0 or 1. What would you like to do? Options are Q, 0, or 1. Well, let's go ahead and put in a 1. Should be legal, right? And it should spit out a 1. Okay? We entered a 1, had no problem with that. It read it in and spit it back out as our answer. Put in a 0. Yep, so it's working. I'm not responding to it yet, but it is working. This makes sense? Okay.
Mine has bugged really.
So what we've done is we've put all of our logic into get input for legal moves. And we don't let get input return until we have a legal move. All right. Now, answer holds our answer. If answer is equal to -1, we want to quit, whatever that's going to mean for our game. Else, answer must be equal to a legal room index. Does that make sense? We wouldn't have gotten an answer back from it if it wasn't a legal position inside of our exits, our exits linked list. Okay, so we need to move into the next room. How do we do that? What does it mean to move into the next room?
Moving, like choosing.
Well, we have our cave is an n-ary tree of rooms, right? And right now I'm in the entrance to the cave. When I enter an exit, when I choose one of the exits, I should move into that next room, right? How do I enter a room? Right now, the method we're in is the display method for a cave, or for a room rather. Display method for a room. And that guy got called from our cave's play. What I'm going to do here, and this comes back to semantics, I'm going to change the name of the method to not say display. Instead, I'm going to change it to say enter. All I'm going to do is change the name of the method. And it's all automatically going to be easier for us to conceive. So this guy's no longer called display. Now it's called enter. How do we go into a room? We enter it. That makes sense? Inside cave, when you play the game, what do? Well, we enter the entrance. I've literally changed none of the code. I just renamed the method. Just by renaming the method, you see how it's easier to conceive of now? So I entered the first room. Now inside that room, if I'm inside that room and I have chosen to go to a different room, what do? Well, I need to get that room first. This dot, the exits dot, get the room at bucket answer dot enter. That make sense? I don't need to check to make sure answer is legal. I know it's legal because of all the rigmarole I went into inside of get input. Get input will not return for me until answer is a legitimate answer. So if it's not -1, meaning I should quit, I know for a fact it's a legal bucket inside of the exits. It's one of those rooms. Okay, so what am I going to do? I'm going to get the room that he wants to go into, and then I'm going to enter it. So let's go ahead and run this. Now, what does enter room do? It displays that room, displays its exits, blah, blah, blah. So here I have 4 rooms, so it's a fairly small cave here. No treasure in the first room. Obvious exits are 0 and 1. I'm going to choose to go to exit 0. When I hit enter, it's going to enter me into that room. Now I'm in a new room. Ah, there's a pot of gold in this room. Obvious exits, well, I can either quit or go into the one exit. So let's go into the one exit. Oh, another pot of gold is in this room. Obvious exits, none, so I'm done. So I can hit quit and the program just ends because I just got into this if statement right here. That make sense?
Why, if we, I mean, it gives us bad input when there's none of exits. Like, it's not giving you a bad input by mine.
Well, I just hit Q. I exited because I was out of exits. I said none. It said, what would you like to do? My options were just Q.
Mm-hmm.
The only option I could have given it there was Q. Otherwise, it would have just kept asking me, what would you like to do? So I hit Q. Q came out of here. Answer was -1. I'm sitting right here.
Okay. But
Program's done because I'm not responding to that yet, but that's what's happening.
mm-hmm.
So what's your question?
Why is it's showing you obvious like answers? 1, 2.
Yeah, okay, so here, let's walk through it.
Yeah.
So here's a small cave. We have 6 rooms in the cave, and there's only 1 treasure in the whole cave.
Mm-hmm.
Okay, so here's our first room. This is our first room. Its name is a room. There's no treasures in here. The obvious exits are 0 and 1, and then it's asking me, what would you like to do? The options I can enter are Q, 0, or 1. So what would you like me to enter?
0.
When we go to 0, okay, so I'll hit 0. When I hit 0, it will return. I will then enter room 0, and it will show me room 0. So this is my new room.
Mm-hmm.
In this room, there's a pot of gold. Except we hit the end of the road. No more exits. But I did get some gold.
Mm-hmm.
I'm not collecting it yet, but that's our next step. Okay, so what are my options? Well, I don't have any exits. My only option is to quit. Okay, but at least I got some gold.
Okay.
That makes sense?
Mm-hmm.
So are we able to traverse our cave now? Yeah, we're walking through our cave using object-oriented techniques. All I changed here inside of room was I named this method enter instead of display. And by doing that, it allows us to conceive of going inside of a cave. When we play, what do? We enter the entrance to the cave. Once I'm in the entrance, what does it do? Entering shows me all the information about the current room, then asks me what I want to do until I give it a legitimate answer. Then, assuming I picked another exit, I enter that room over and over and over again. So this allowed me to snake all the way through my cave. Make sense? Okay. But when we come upon a treasure, we need to give ourselves credit for that treasure. Okay? So, right now we have this thing called stats. Stats has a number of rooms associated with it. It also has a number of treasures associated with it. That's the total number of rooms and the total number of treasures. We're going to create two new stats. Private static int num rooms visited. Start that off at 0. And then num treasures found.
So you're not counting first one,
Well, we will. It'll count itself. You'll see.
Okay.
Initially, I haven't visited anywhere. As soon as I enter the cave, it'll go up to 1. Okay. So here's the start value for all these. I'll go ahead and update my reset method to also reset those other values. So num rooms visited is equal to 0. Num treasure found is equal to 0. Make sense? So that's what it means to reset this object. Add room and add treasure get called when we are creating our cave. What we want to do to have a method called entered room, which calls num rooms visited plus plus. That make sense? We also want to have a method found treasure. And that'll increment num treasure found. Okay? Then we want to be able to get both of those things. Public static int get rooms visited. This guy will return num rooms visited. Then we want to have a public static int get treasure found. And this guy will return num treasure found. Make sense? All right. Now, come back into room now. Every single time we enter a room, the very first thing we're going to do is we're going to say stats dot entered room. Every single time, right? We enter a room, we will mark off, we just entered a room. If this room has a treasure, we'll also say stats dot found treasure.
Okay.
Make sense? So in the exact same question that we're using to print out whether or not we see a pot of gold there, we're also going to mark that we found a treasure. Okay? Down here at the very bottom, when they say quit, what are they going to do? What are we going to do? We're going to say system.out.println rooms visited stats, that's a capital S, stats.get rooms visited System.out.println treasure found stats.get treasure found. Make sense? So now when we run this, what a crappy one room cave with one treasure. So when we hit Q, it should say we visited one room and we found one treasure. Visited one room, found one treasure.
Okay.
Great. All right. 68 rooms. Okay. So no treasure in the first room, but let's go to exit 1. No treasure in the second room. Let's go to exit 1. Oh my gosh! 68 rooms. I found no treasure and only visited 2 rooms. 3 rooms. The first one and the next 2 exits I went into.
Okay.
Man, that was bad luck, right? Okay, so let's go 1 again. Pot of gold. Good. Oh, but no exits. Oh, but there's only 3 rooms there. 2 visits, 1 treasure found. Make sense? So is this? I think this meets the requirements of the homework.
Yep.
So all the complexity of this was built into this get input method right here. All that guy says is, here's what you can do. Give me some input. I'll keep asking you until you get me something that's legit. Okay? So now that we built that functionality, we can make enter work more cleanly. What do we do at the end of enter? Well, we get the input. So rather than having all that code hanging in here, making enter look big, we just have this one little line, and we know that this guy does not return until what occurs? Until all the other stuff has been checked. And we know we have an answer that's legit. Okay? Make sense?
We want to go to the stats again. I want to just check something wrong.
What did we do to stats? We took the exact stats we had before. We added 2 new fields. Added those fields to the reset, which we never actually use right now, but we will. Okay? And then what did we do? We created 4 methods. 1 to increment the number of rooms visited, 1 to get the rooms visited, 1 to increment the number of treasures found, well, get the number of treasures found, and 1 to increment the number of treasures found. So 4 simple methods surrounding 2 new fields. And these guys are static. Static means they belong to the class. Why do they belong to the class? Because we are keeping track of global stats for our entire game. Does that make sense? Now, as of right now, what would you say is the greatest weakness of our game? Might it be that sometimes we run it and we only have 1 room? That we probably don't want to have 1 room caves, correct? We would probably want to generate a cave over and over again until it met a certain minimum threshold. Does that make sense? So here's our cave. Our cave creates a new room. Now, after we create this room, that's going to start off that whole random process of growing this cave, correct? What if my cave is not big enough? Might I want to just create a new cave? True statement? Let's build a new cave. Well, let's say that the constructor for cave takes in actually instead of min size, let's say min number of rooms. And we don't want to leave this constructor until we've guaranteed ourselves that we've created a cave that is big enough to hold a min number of rooms. How would I ask that question? After this line of code, has my cave been created?
The rooms created. Yeah.
That's a cave, right? How many rooms just got created?
1. This and then it goes to.
Well, new room calls the constructor for room, right?
Oh yeah.
Here's the constructor for room. What does this guy do?
Like a number.
Possibly creates more new rooms.
Yeah.
So we know at least one room got created, potentially, probably more than one room, right? So after this line of code, our cave has been built through all those recursive calls. Well, partially recursive calls. It's just the rooms constructor calling another room constructor, but it is the constructor for a different room. But now I don't want to let this go until my number of rooms is at least min number of rooms. How many times am I going to have to try to build the cave? Will I have to try to build it at least once? I'm going to have to build the cave once and then check to see if it has enough rooms, correct? Mm-hmm. I will have to build it at least once. So we have a loop that allows us to build something, that allows us to do something one or more times. That's the do while loop. So I'm going to say do this while what is true. I want to keep building a new cave as long as the number of rooms in that cave is less than minimum number of rooms. How do I ask that question? How do I say while the number of rooms in the cave is less than minimum number of rooms? If that's true, what do I want to do? Build a new cave. So how do I ask the question? What's a Boolean expression?
1 or 2. 1 or 0.
Any expression that boils down to a single value of true or false. Remember that? Yeah. Okay? So I need to write a Boolean expression here that asks the question, does the cave that I just built have a number of rooms in it that is greater than or equal to the minimum number of rooms expected? How do I ask that question? Who knows about the number of rooms that are in the current cave?
Like the constructor of the room.
No.
We don't know.
You know. Who knows about the number of rooms in this cave? It's the same guy that knows about the number of treasures in this cave. It's the same guy that knows about the number of rooms we visited in this cave. It's the same guy who knows about the number of treasures we found. Who knows about how many rooms this cave has? It's on the screen. It's one of these 4 tabs. Which one of these guys knows how many rooms was created? Stats. Stats knows. So while stats.room count, while that is less than min number of rooms. If the number of rooms that we just created is too small, what do we want to do? We want to create it again. But before we create it again, and even before we create it for the first time, we want to say stats.reset. That's where our reset comes in. We want to zero out everything before we build each cave so that when we ask this question, we're not asking this cumulative number of rooms. We might build 30 caves in a row and come up with our minimum number of rooms, but the ultimate cave that we just built might only have 9 rooms in it. That make sense? All right. So what are we going to do? This is a do while loop is a post check loop. That means we execute the body of the loop at least once. So we'll come into the constructor for cave. We'll reset our stats. We will let the recursion build out our cave. So this basically grows us a cave. Then we ask the question, if the number of rooms we just built is not enough, what do? Reset our stats, build it again.
Okay, so we'll create a reset button now?
That's what this does. Stats reset. We already wrote it.
Mm-hmm.
Here's our reset. Reset puts everything back to its initial state.
Okay.
Okay? So we zero out our stats. We let our cave grow, which should then modify our stats. Then we ask our stats, tell me about the cave we just grew. Is it too small? If it is, reset our stats, build a new cave. Is it still too small? If it is, reset our stats, build a new cave. As soon as we get a false here, we know that the cave we just built meets our minimum requirements. That make sense? What that lets us do now is inside of driver, when we build our cave, we can say the smallest cave we want to allow it to build is 15. Now we're guaranteed that when it prints out the number of rooms and the treasure count, we are guaranteed to have a cave that at least has 15 rooms in.
Okay.
Why? Because that's what we passed into our cave constructor. We passed in a number. That number was the minimum number of rooms. And we kept growing a cave until we got at least that number of rooms. Make sense? Okay, so we'll run this, and we're going to have definitely at least 15 rooms. There we go, we got 28 rooms. 14 treasures. Okay, no treasures in the first room. Let's go to 1. Still no treasure. Let's go to 1. We got a treasure. Let's go to 1. Got another treasure. Let's go to 0. End of the road. But I did find 2 treasures, and I visited 5 rooms. Make sense? Okay. Now, let's say I want to go back to the beginning of the cave. So kind of a start over. Maybe B for beginning. Q to quit, B to beginning, and then 0, 1, blah, blah, blah. Make sense? Well, let's do that.
Yeah, but you said we can't begin again in the cave, so.
Well, no, we've already passed the end of the homework assignment.
Yeah.
This is new stuff.
Okay.
Yeah, this is new stuff. Homework assignment was over a while ago. Yeah, this wasn't even part of the homework assignment. Yeah, this whole thing, we're adding new stuff now. Make sense?
Yeah, that's what I was thinking.
Yeah, this is new stuff. Not part of the homework.
Yeah, we already reset in the stats method, so.
Right. Yeah, now we're just using some of those things that we previously wrote. Okay, so now we want to allow us, so if we're playing our game here, my options are Q, B, to go back to the beginning, or 0. Okay? So Q is kind of like giving up. B is like, okay, I hit a dead end, but there's more rooms to explore. Okay, so let's go back. All right, so we're going to go into room. Get input is the guy that knows about Q's and B's. So I'll expand get input to say my options are Q, B, or whatever else comes next. If they entered in a Q, we're going to return a -1. If they entered in a B, we need to return something else. Maybe a B is a -2. That means go back to the beginning. -1 means quit, -2 means go to the beginning. So we'll return -2.
Why?
I mean, for all I care, we could have returned 74 or 73. We're just picking an error code, if you will. Okay, so I've just decided that -2 means go to the beginning. That way we can interpret whatever comes out of get input. So if they enter in a Q, return -1. If they enter in a B, return -2. Otherwise, do all the stuff we used to do. That allows us to go down here to enter. If the answer was -2, we're going to quit. Else if the answer was -2, this means go back to the beginning. Make sense? Well, here's the question. How do we do that?
By the reset button.
Well, I hit the reset button already. I already hit B. If I'm here, that means that I entered a B.
Okay.
And I want to go back to the beginning of the cave. How do I get to the beginning of the cave? Where is the beginning of the cave?
Room.
Well, I'm in a room right now. I'm in some instance of the room class. But I'm very likely, if I just hit B, I'm very likely not in the beginning of the cave. I'm somewhere down in the depths of the cave, right? And I've decided, okay, I hit a dead end, or I think I took a wrong turn. I've decided I want to go back to the beginning. So I hit B. I'm supposed to go back to the beginning. Question is, how do I get there? Let me kind of draw this out for you. Let's so we can understand the way we're currently going about this. So we'll add a slide here. So this is our cave. So let's say that's the beginning. And let's say we had 2 exits off of there. And we had 1 exit here and 1 exit here. Okay? Now, we started at the entrance of the cave, right here. From there, what did I do? From there, I decided, okay, well, let's go to exit 0. Then from there, I decided, let's go to exit 0. Now I'm right here. I'm at a dead end. So I decide I want to go back to the beginning. How do I get back to here?
Okay, you want to...
I'm in a room.
Okay, you want to go back to the beginning.
Right. So now let me show you what we're really looking at here. This is my cave. So the reddish color thing is a cave.
Mm-hmm.
A cave has an entrance. So my cave has a field called entrance. Show that to you right here. Here's my cave. Caves have a single field called entrance, and that entrance is a room. So here's my cave's entrance variable, and it points to the room that is the beginning of the cave. Now I'm telling you, I started in this room, then I went to this room, then I went to this room. So I'm currently sitting in this room right here. And I hit B, meaning I want to go back to the beginning. How do I get there? Now we have to start thinking in terms of objects. Who knows about the beginning of the cave?
Cave.
The cave knows. Where am I?
You are in the room.
I'm in a room. I'm in this room.
Mm-hmm.
Do rooms know about the beginning of the cave? They do not. Only the cave knows. So if I'm in this room and I need to get back to the beginning of the cave, and only one person knows about the beginning of the cave, who am I going to have to talk to?
Play in the cave.
I'm going to have to talk to the cave. If I'm in this room, do I have access to the cave? As of right now?
No.
If I'm in a room, I don't have access to the cave. I don't know about the cave that I'm in. I know I'm in a cave, but I don't have access to them. Okay, it's like my email's down. I don't have a good cell phone service. Okay, I can't call them. So I need to somehow notify the cave that I need to return to the beginning. I need to know where the beginning is. Similarly, I mean, let's just talk about even a simpler problem, or a similar problem, but a different problem. If I'm here and I want to get here, how do I do it? Does this room know about this room? No. This room knows about this room. We took the exit to get here, right? But this guy only knows about his exits. He doesn't know about the room that he came from. Does that make sense? So we have to, as we're looking at these objects, we have to understand that we're working out of a position of ignorance. We only know what we know. And if I'm in this room and I need to get back to the beginning, the only person that knows about the beginning is the cave. So I need to be able to talk directly to the cave. How do I do that? How would I pull that off?
You want to go back?
Well, I want to talk to the cave. Forget what I want to ultimately do. I'm just telling you, well, you told me, really. You told me that the only person who knows about the entrance to the cave is the cave. Right? Okay? Well, I'm in a room right now. And I know that my ultimate goal is to get back to the beginning of the cave. You told me that the only person who knows about the beginning of the cave is the cave. So what I'm telling you now is I need to talk to the cave. So how do I talk to the cave? How do I ask the cave anything? I need to give myself access to the cave. How do I do that?
Creating new.
Like we had to, like create a new display method in the cave to, like restart again.
Well, I can't talk to the cave. I'm right here. I'm standing inside this room. That's my dead end. I'm in the cave, but I have no way of talking to the cave.
Is it something linked with the linking in back to the...
Yeah, we can talk to the cave with the same room which we entered from. Yeah, that's the.
But I'm not in that room. You're right. If I was in this room, I'm already at the beginning. But I'm not in that room. I'm in this room. The cave has a single field called entrance, and that entrance knows about the first room. But I'm not in that place. I'm way down here. This goes back to our linked list example. If I'm here and I want to get to the front of the list, who do I need to talk to? I need to talk to the linked list who knows where the head is.
Yeah, and before we talked to the cave, we had to quit from the cave first.
We don't want to quit.
No, we're not going to quit. We give ourselves a new option, B, to go back to the beginning.
Okay. We will be speaking with the one ahead of cave, one before one. Like one after room cave to go in speak with the cave.
Mm-hmm.
Which would be the first room. We have to link ourselves to the first room back.
Okay, let's ask this a different way. Let's say that we're deep sea divers. Okay, we're looking at the wreckage of the Titanic. You all know what the Titanic is, right? Big boat ship, big boat sank because of iceberg thingy.
Yeah, in 2001 or 999, the new film.
Well, that was a movie.
Yeah.
With the,
yeah,
there was a real boat once upon a time. All right, so we're on this expedition. Okay, we're looking for the shipwreck. Now we got to decide which one of us is going to go down, go into the water.
Abdullah.
Well, who could hold their breath the longest? Habib? He just volunteered you. Okay, so Habib, how long can you hold your breath?
5 minutes.
Oh.
5 minutes? Okay, you can hold your breath the longest then. All right, how long is it going to take for you to go under the water and find the wreckage? More than 5 minutes?
Yeah.
Probably, right? So is that something are you just going to swim under, hold your breath, and come back up, and then catch your breath and go back down and hold your breath? What are you going to do?
Yeah.
You take air with you. But where's the air? The air's up here. When you're under the water, where's the air? The air's up there. So what do you have to do? You have to take the air with you so that you have access to air while you're down there. So you can do a couple things. You could take a tank that has air in it, right? Or kind of the old school way of doing some of this, what you go down, you have like a hose.
Yeah.
So somebody up top is above the water. You know, how many of you ever used a snorkel? You don't know what a snorkel is? You go swimming, put it in your mouth. It's like about that tall. So, you know, it's a pipe that allows you to be under the water, but not too deep, right? Just a little bit under the water. But you have a little pipe that comes up above the water so you can breathe. So what are you doing? You're giving yourself access to the air, even though you're under the water. I'm giving myself access to this cave, even though I'm well within the cave. How do I need to do that? Well, I'm going to have to take the cave with me.
Or link?
Take a link with me. Maybe I'm going into the cave and I'm dragging a rope with me. Okay? The rope is way back at the beginning. Okay? And at the end, I could tug on the rope and say, okay, pull me back. But chances are, you know, it's going to be, think about more like a Star Trek or something where we're going to get beamed back.
Yes, sir, you know, so we are not using the other room which we already entered. So like how we can get the link from?
We're going to have to add it. We're going to have to modify the way we're building our cave so that each room knows about the very least, each room knows about the cave's entrance. Does that make sense? Mm-hmm. So, we're going to modify room. When a room gets built, a room knows about the cave that he belongs to. So the constructor for room, so I added a field to room of type cave, named it the cave. Now a room is going to take a cave as a parameter, and we'll set this dot the cave equal to the cave, whatever cave was passed in. When we build new rooms, like we're doing right here, we're going to pass the cave along. So every room knows about the cave he lives in. We set it in the constructor right here. So a room takes in that cave. And a room builds new rooms, right? Every single time we build a new room right here, we pass it the same cave that we lived in. So we're passing a link to the cave all over the place every single time we create a room. Make sense?
Mm-hmm. Okay.
Does everybody understand that so far? I'm about to ask you a hard question. It may impact your grade. We're asked questions now. So every room knows about the cave. When we build a room, when we call the constructor for a room, we're going to pass it the cave that we're in. Make sense? We're going to store that cave inside of a field that a room owns. Similarly, when a room spawns off its own rooms, how it grows with its exits, we're going to pass that new room the cave. So every single time we build a room, we're passing it a link to that cave. So every room knows about the cave. So that later on, we can then ask, when we want to return to the beginning, we can say, the cave, give me the entrance. That's where I want to go. That make sense? Like pulling out a walkie-talkie. It's like, cave, I'm ready to go back to the beginning. Cave says, okay. And what does the cave do? It provides you the room that is the beginning. And you can enter that room. So the question is, this is our room object. The room object creates multiple rooms themselves. But who creates the first room? Cave. Here's our little diagram. Cave created the first room. Okay, so you ready for the hard question? So I'm going to go back to cave. When I build a room, I'm going to set this cave's entrance to a new room. What do I pass in right here? A room expects me to give it what? The cave that he lives in. So what do I pass right here? I need to give this guy the cave. Very, very, very important object-oriented concept here that you should know the answer to. I'm not asking you to pull something out of memory. I'm asking you to look at the screen and interpret what's here. I am inside the cave object. When I'm building a cave, right here, one of the requirements of building a cave is that I build at least one room. And I know that that room will build more rooms likely, right? The issue is in order to build a room, the guy who I know, the constructor for room, requires that I pass him a cave in order to build that room. Well, I'm inside of cave. How do I pass a cave to him?
By linking?
I'm asking you specifically, what do I type here? I'm going to type one word in here. What's the word that I type in there? And it's not linking. It's not that word. So I'm inside of the cave. The very cave that I want to let this room know about. Correct? The constructor for this room requires that I tell it about the cave, about myself. I'm the cave. How do I let him know about myself? Somebody in here has to know this answer. Well, no, somebody other than me has to know this answer. How does an object refer to themselves from within themselves? I just asked the exact same question in a different way. If I am cave, if I am in this particular instance of cave, how do I refer to myself? Because it is in fact myself that I want to pass into the constructor for room. Correct? I want to give them a link back to me. How does an object refer to themselves from within themselves? Every one of you in here knows this. We use it constantly. It's written on the screen right now a couple of times. So we've used it twice on the screen right now.
Is the counter?
What counter have we used on the screen right now? Do you see any counters on the screen?
Yeah, we can use like this dot room.
This dot room?
Yeah. So we are calling the room. Okay, we are getting back the same.
So this dot room, that's what you want me to type, is this dot room?
Yeah.
Like that? Well, where did this come from?
No, we are going back to cave again at the beginning. So we are going.
Well, I mean, I know what you're trying to do, but I'm asking you is this dot room, where is this guy? I don't see any, I see entrance. I could say this dot entrance.
Yeah, sorry, this dot.
So you want me to pass this guy this dot entrance?
Yeah.
What kind of animal is this dot entrance?
It's room.
It's a room. What kind of animal does the room constructor require?
Cave.
Is a room a cave?
Nope.
Different guys, right? A room is not a cave. A cave contains rooms, but a room is not a cave. So this constructor expects a cave. What we're doing right now is we're passing it a room. So that's not going to fly. but close. How does an object refer to itself from within itself? This is perhaps the most important attribute of object-oriented languages. Without this ability, object-oriented programming breaks. An object must be able to refer to itself from within itself. How do you talk about yourself when you're talking to somebody else?
Somebody else?
Yeah, if I'm talking to you and you're telling me that, oh yeah, I went out to, a restaurant last night. Do you say that? Oh, Farouk went out to a restaurant last night. Is that what you say? Talked about yourself in the third person. What do you say?
I.
You say I.
Yeah.
I went to a restaurant last night.
It's not cave then?
Do you see any variable in here named cave?
Class cave there. Verbal.
Did you just say I dot Farouk? Or did you just say I? This. Objects refer to themselves within themselves using the keyword this. Just like human beings refer to themselves within themselves using the keyword I.
Okay.
That make sense?
Yeah.
This particular instance of cave, inside of here, since we're inside of the cave, is known as this. Does that make sense? Super, super, super important. That's a concept that you should have learned in 535. Super important. Okay?
Yeah, like we are moving back to, from other room where we came from. So can we use this dot move?
Well, no, hold on. So let me stop you there. So what you're doing right now is something that a lot of beginning programmers do, is you try to invent things that are not there. You could write a method or something like that, but the point is that I asked Farouk a while ago. I said, if this is our picture, if we're in this room right here, this is where we're at, okay? And we need to get here. Who knows about this room? And he told me the cave knows about that room. The only guy that knows about the entrance of the cave is the cave himself. This room doesn't know about the entrance of the cave. This room doesn't know about the entrance of the cave. This room doesn't. This room doesn't. This guy knows about himself. He refers to himself as this. But that's not where we are. We're right here. And I asked Farouk, who is the only guy in this whole picture that knows about the entrance of the cave? And he said, oh, well, it's the cave itself. So if the cave knows about the entrance, who do we need to talk to in order to get to the entrance? Well, we need to talk to the cave. So what did we do here? We gave every single room access to the cave. That make sense? Now, since every room has access to the cave, a cave can provide a method maybe called getEntrance. And this guy returns this dot entrance as a room. Make sense? Because every single room has a link to this cave. And this cave can provide us the entrance inside of a room when we want to go back to the beginning. What will we do? We'll say this dot, the cave dot, get entrance dot, enter. Does that make sense? So if I'm in a room and I've decided I want to go back, I'm going to talk to the cave. That's how we access the cave. This dot the cave is this particular instance of room, his field called the cave. So I'm saying, cave, give me your entrance, which will boil down to a room. And then I'm going to enter that room. That make sense? So we provided ourselves with that method to get the entrance, assuming we knew the cave.
Yeah, cave give like entrance to like first room. Like what are the other rooms? Like if you get the entrance to the other rooms which we enter.
All a cave knows is about the entrance, just like a linked list only knows about the head.
Yeah.
So if we're in this room, who knows about this room?
Yeah. First room.
This guy. Who knows about this room? This guy. Who knows about this room? This guy. So all of our knowledge about this cave is spread around the cave. The only person who knows about this room is this room. The only person who knows about this room is this room. The only person who knows about this room is the cave. Does that make sense? So all of our information is disjoint. All the rooms don't know about all the other rooms. But what we've done now is we've said, you know what? Every single room in here now knows about the cave. So every single room can quickly port back to the beginning of the cave by saying, cave, give me your entrance and I'll enter that guy. That make sense? So just by putting that little code in there, now I can walk through here. Here's 37 rooms. So we're going to go ahead and we're going to say 0. Oh, we have an exit to 0. Okay, so I got another pot of gold. Another exit to 0. Ooh, no treasure, but another exit to 0. Okay, no obvious exits. So now I'm going to hit B to go back to the beginning. It's going to take me back to the beginning of the cave. Now I'm going to hit 1. 0, 1, 1, 1, 0. I'm at the end of the cave. I can go back to the beginning, so on and so forth. So I can just keep going through this cave over and over again. Now the goal would be to ultimately get rid of all the treasure. Does that make sense? Okay, so now I can go through the cave as many times as I want. When I hit a dead end, I can go back to the beginning, try again, but I want to ultimately collect all the treasure. When I first run this, I am told there are 10 treasures in this cave. So in order to beat this level, if you will, I need to collect those 10 treasures. Right? How would I do that? I'm already collecting them, but I want to see a countdown, like treasures left.
Maybe with the temp, putting our treasure in the temp, whatever we collected already.
Yeah, we can add like number of treasure left in the cave. So,
Okay, how many treasures are left in the cave?
like how many rooms we are not visited, so it will be take minus from them.
Well, how many treasures are in the cave?
Now 0.
Stats dot get num treasures. How many treasures have we found? Stats dot get treasure found. How many treasures are left?
Minus.
Stat dot get treasures minus stat dot get treasures found. That's how many are left.
Mm-hmm.
Correct? But now every single time we find a treasure, what do we need to do?
We need to keep it.
We need to collect it, which then removes it from that room. Does that make sense? So when we collect a treasure, right now, whenever we enter a room and we collect that treasure, we're doing it right here. Here's enter. If we found a treasure, we're going to print out a pot of gold. We know we just found a treasure, right? But then what are we going to do? After we collect it, this dot has treasure is equal to false. That way we don't collect the same treasure more than once. Make sense? So when we first enter this room, if it has some treasure in it, we'll collect it. We'll print out that there's treasure here. And then we'll make it so that the next time we enter this room, there's no treasure here. That way we can't collect the same treasure more than once. Okay? So every single time we enter a room, we probably want to see the number of treasure remaining. Okay, right now we're giving ourselves this big stat here. Number of rooms, the number of treasures, so we kind of know the beginning. You know, the beginning point. But we're going to go ahead and we're going to print out for every single room we enter. Treasure remaining is what? Stats dot get treasure count. Stats dot treasure count minus stats dot get treasure found. Okay. So every single time we enter a room, it's going to tell us how much treasure is remaining in the cave. That is the amount of total treasure that was in the cave minus the number of treasures we found. That's how much treasure is left in the cave. And every single time we find a treasure, we'll increment our treasure found and then make sure that we can't find the same treasure more than once. Because our goal here is to clean out the cave. That's when we've beaten this level. Hit play here. Number of rooms, 23. Number of treasures, 13. Treasures remaining, 13. Okay. Well, we have no treasure here in the first room, so let's go to 0. Still no treasure. Let's go to 1. Ah, there's treasure here. Let's go to 1. We should have 12 left. 12 treasures left. Ah, no exits. Got to go back to the beginning. Still 12 left. Let's go to 1. Ah, I got another treasure. Let's go to 0. Got 11 left. Let's go to 1. Ooh. We got 9 left. Let's go to 0. Got 8 left. Well, okay, we're done. Back. Now we got to remember where we've gone and where we haven't gone. Let's go to 1. Let's go to 0. Let's go to 0. Good. Okay, so we got a pot of treasure, pot of gold. Let's go to 1. We have 6 remaining. Ah, we're none. We got to go back. Let's go to 1. Let's go to 0. Let's go to 0. Let's go to 0. Okay, we got another one. Go back. Got 4 left. Somewhere in our cave, we have 4 more treasures. Let's see. Let's go to 1, 0, 1, 0, 0, 0. No. 1, 0, 0, 1. 1, 0, 0, 0. 0, 1, 0. Ah, got another one. 0, 0, 0. Back to the beginning. Okay, I got one more pot of gold I got to find in this thing. This is a fun game, isn't it? One more pot of gold. Okay, let's see. 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0.
If we cannot then, if we quit, they could show where was that.
Why would you ever quit?
No, I mean,
Are you a quitter?
No, but just.
Yeah, we got remaining 0.
Oh, we found it? Okay. Ha! We beat the game. Okay. So let's take about a 15-minute break. When we come back, we're going to add some more competition to this where we can only find the treasure. We only have so many moves to find the treasure. That make sense? So we can find as many treasures as possible with a certain number of moves. Kind of like, how many of you have played Candy Crush?
Oh.
We've all played Candy Crush, right? Or many of you have played Candy Crush. The puzzles aren't hard if you have an infinite number of turns.
Yeah.
But you're not. You have a certain number of moves you can make. And you have to beat it in that number of moves. So we're going to have to come up with some sort of way of limiting them to the number of moves they can do. Where a move is taking an exit or going back to the beginning. Does that make sense? All right, so let's come back around 8:20. Take 15 minutes. And I'll see you.
Okay.